So in this video, I'm going to talk about important tips for O-Level Physics 5054 P1 exam. And this video is especially very important for the students who are appearing for the mini exam series right in few days. So what you have to take care in this exam is that the time management is of prime importance, right? So you need to spend 1.5 minutes on each question since there are 40 MCQs, right? 40 MCQs, and the duration of the exam is 1 hour, right? So 1.5 minutes on each question is sufficient to manage the time well, right? Do not exceed this time limit. If you exceed this time limit, it's going to cause problems, right? If you are exceeding 1.5 minutes, just move on to the next question, and later on you'll get the idea about that specific question, right? When you are attempting other questions as well, right? The other thing that I really need to emphasize is that read the question and infer the meaning from the statements. You should remember that half of the answer is usually lies in the question. So read the question properly. Read the question and infer the meaning from the statements. There is another important thing that is sometimes in the question there are bold letters, right? What is not the correct answer? They've asked in the question what is not the correct statement for this question. So you have to see that properly. Bold letters are of very prime importance. Are of prime importance. Furthermore, you'll be provided with the grid. Use a sharp pencil to fill the grid and fill the grid simultaneously, right? Fill the grid at the end, since at the end you will have to rush in order to solve the entire that grid. So fill the grid simultaneously, right? When you're solving questions, right? And not at the end. Furthermore, omit the options and make intelligent guesses, right? Do not leave any MCQs because there is no negative marking. So make intelligent guesses, omit the options, and that will really help you a long way, right? Omit the options and make intelligent guess, right? Leave no questions as there is no negative marking, right? As there is no negative marking. Moving towards the physics of this exam, right? What students do is that they confuse the units, right? They confuse the units of power, energy, work done. So you should know the units pretty much well, right? So the units are confused. Make sure you know the proper units. Units of force, energy, and power are some of the units which, the unit of force is Newton, the unit of energy is joule, and the unit of power is watt, which is equal to joules per second, right? So they are different units. So these units are confused by candidates who are not certain at the exact definitions of these quantities, right? So make sure you know this, right? Number two, when numbers are substituted in the expression of kinetic energy, that is 1/2 mv square, what students do is that they omit taking the square, right? So when they perform the calculation, they ignored the square, and that leads to an incorrect answer, right? So make sure you know this. Number 3, what students do is in the topic of elastic deformation, they know the term limit of proportionality, which is a syllabus term, but they frequently refer that as elastic limit. That is not a syllabus term. The elastic limit is usually a different point than the limit of proportionality, right? They are different points. Limit of proportionality and elastic limit are different things. So elastic limit is not a part of O-level syllabus 50-54, right? So make sure you know about the limit of proportionality only, right? Limit of proportionality. Number 4, you should know that for equilibrium, there must be no resultant force and there should be no resultant turning effect, right? If an object is in equilibrium, there must be no resultant force and no resultant turning effect. Usually what the students do is that they forget about the second requirement, right? They do not mention it, right? So you should know about both of these aspects, right? The students are usually, sometimes they're asked about the difference between a scalar and a vector quantity. So a vector has a magnitude and a direction, does not make it clear that it is the direction that is of difference rather than the magnitude. So basically a vector has a direction which differentiates between a scalar and a vector. So you should know about that as well, right? Moving on, for the part of efficiency in work, energy and power, what students do is that sometimes they only write output over input, which is not right. What you need to understand here is that it is useful output energy over total input energy, right? Or useful output power over total input power, right? The energy should come twice upstairs and downstairs, right? And power also in the numerator or the denominator, right? It should come twice, right? So you should know about this expression, right? That output over input is not sufficiently precise. You have to use energy twice and the term of power twice, right? So you should write useful output energy over total input energy if you require efficiency. Or similarly, useful output power over total input power, right? If you want to write it as a percentage, just multiply it with 100 in order to a heated gas, right? This is another important thing that you should remember, right? So let's say you have a heated gas. The pressure inside the container is caused by more frequent bombardment of the molecules against the container walls, right? There are more frequent bombardment, right? If you only write that there are more collisions, that is simply not enough, right? The phrase that there are more collisions is not enough. So you have more frequent bombardment of the molecules against the container walls, right? There's another important thing is that the expression PV is equal to constant. What students think is that the pressure and volume are they are interpreted by the students as they are directly proportional, right? Some of the students. But you should know that the pressure and volume are inversely related to each other. And that's why if we use this mathematical term, P divided by 1 over V is equal to constant K, that will basically give us what? That will give us exactly the same expression. PV is equal to K, right? So pressure multiplied by the volume will give us a constant, right? But pressure and volume both are inversely related to each other, right? You should know this, right? Topic of convection, what you have to recognize is that the difference between more dense and less dense, right? So what you need to recognize is that the heated gas expands, it becomes less dense and rises, right? What students sometimes confuse is that they write that they think that it becomes more dense. That is not the case. It becomes less dense. When it expands, what happens? The volume increases. When the volume increases, the density goes down. So that's why they become less dense and they rise, right? You should also know about the fact that the sensitivity is, this is a very important thing, that sensitivity of a thermometer is change in length per unit degree rise in temperature, right? Change in length per unit degree rise in temperature, right? For example, it is degrees Celsius, right? The change in length can be millimeters, right? So you should also recognize that it is not dependent on the thickness of the glass in the bulb, right? And you should know that sensitivity increases with more amount of liquid in the bulb, and if the diameter of the bore is reduced, right? The narrower the diameter, the more would be the sensitivity, since there would be a greater change in length per unit degree rise in temperature, right? So this is something that you should remember by all means. Another thing here is that heat is given out when the liquid solidifies. The heat is not taken in by all means, right? And when a solid converts into a liquid, or when liquid converts into a gas, the heat is taken in, right? So you should know this stuff by all means, right? And remember that whenever there is a change in state, you have to use the formula Q is equal to Lm, right? L is the specific latent heat of fusion. If a object is solid to liquid, it is converting into from solid to liquid, and it is latent heat of vaporization when an object is converting from liquid to a gas, or vice versa, right? And Q is the latent heat of fusion or latent heat of vaporization, right? This is the specific latent heat of fusion or specific latent heat of vaporization, right? And you can only apply this formula when the temperature is not changing. And when the temperature is changing, you have to make sure that you apply the formula Q is equal to MC delta theta, right? And this occurs in the same state. It can be a solid, right? A solid can have a change in temperature, or a liquid can have a change in temperature, right? Or a gas, right? So make sure that you know this stuff by all means.